When the name Stephen Hawking is mentioned, it immediately conjures images of the cosmos, black holes, and daring theories about the universe's origins. His life represents a saga of perseverance, inspiration, and a monumental contribution to the world of science. As we begin this detailed exploration, I encourage you to see this not as a mere biographical summary, but as a lecture, where every concept guides you further into the profound mysteries of space. Stephen William Hawking was born in Oxford, England, on January 8, 1942, a date that marked exactly 300 years since the death of Galileo Galilei. This was a coincidence that he and his parents often highlighted as a meaningful connection. His early years were quite ordinary, filled with the typical pursuits of a boy who loved building toys and deconstructing mechanical devices. His peers from that time remember him as a student who wasn't especially studious, yet even then, he possessed an immense curiosity about the fundamental workings of the world. Upon enrolling in school at St. Albans, his academic record was unremarkable. Nevertheless, a powerful drive for knowledge burned within him. He developed a deep interest in mathematics, physics, and chemistry, but his greatest fascination was with the stars. Without a telescope of his own, he used any means available to observe the night sky, fostering an ambition to see beyond the limits of ordinary perception that would define his entire life. His parents were both intellectuals. His father served as a physician focused on tropical diseases, while his mother was a librarian. From a young age, the boy was immersed in a scholarly environment, with their home being a haven of books. What was truly significant, however, was the family's emphasis on freedom of thought over rote memorization. This upbringing was instrumental, as it taught Hawking not just to absorb facts, but to relentlessly ask questions. When it was time for university, the decision came down to Cambridge or Oxford. The young Stephen selected the University of Oxford to pursue physics, as mathematics was not yet offered as a distinct major. There he found the academic demands surprisingly light. His contemporaries recall him as someone who rarely studied or took notes, but had an innate ability to grasp the core of any subject. Though he was known for his humor and a somewhat laid-back attitude, his performance on exams was consistently brilliant. It was during his time at Oxford that the first subtle indications of the disease that would shape his existence began to surface. He would occasionally stumble without reason, and his speech would sometimes become slightly indistinct. He paid little attention to these symptoms then, as the full extent of his condition would only manifest itself much later. Fate, it seemed, was already starting to present its challenges. The young Hawking, interestingly, was a far cry from the scientific icon we now recognize. He was social, enjoyed parties, and participated in boating, often appearing entirely carefree, as if destiny were intentionally shielding him from the difficulties that lay ahead. After completing his degree at Oxford, he moved to Cambridge for his postgraduate studies. This marked the true beginning of Hawking's journey as a scientist, a man whose focus turned with profound seriousness to the cosmos, black holes, and the principles that govern our universe. Before we proceed, it is crucial to understand the historical context. The 1960s were a period of immense public fascination with space, fueled by the intense race between the United States and the Soviet Union. As satellites were launched and humans ventured into orbit, the world was captivated by the prospect of lunar travel. Amid this fervor, a young Cambridge student began to explore much more fundamental issues. Not how to get to the moon, but why the universe exists at all, where it came from, and the rules by which it operates. This convergence of a remarkable era of discovery and his own personal inquisitiveness forged Stephen Hawking into the towering figure we remember today. His life would be a chronicle of both immense tragedy and extraordinary achievement. But its origins can be traced back to a simple yet profound question from his youth. Why is there a universe? Arriving at Cambridge, Hawking was now at one of the world's most distinguished scientific institutions, where he started his doctoral thesis in cosmology, the field dedicated to the universe's origin and evolution. His supervisor, Dennis Sciama, a man who had a significant impact on the young researcher, had himself been a student of the renowned astronomer Fred Hoyle, the main advocate for the steady-state theory of the universe. It is essential to recognize that in the 1960s, the scientific community was deeply divided. The Big Bang Theory was just starting to find its footing, while many prominent scientists still clung to the notion that the universe was eternal, without a beginning. As a new postgraduate student, Stephen was thrown directly into the heart of these intellectual battles. His research focused on singularities, points in space-time where the established laws of physics collapse. He was already asking himself, if the universe is expanding, doesn't that logically imply it was once condensed into a single, infinitesimal point? It was during this formative period that his illness made its devastating entrance into his life. At the age of 21, Hawking received a diagnosis of amyotrophic lateral sclerosis, or ALS, a condition also known as Lou Gehrig's disease. The doctors gave him a prognosis of just 2 to 3 years left to live. For a young man at the very start of his scientific career, the news was a catastrophic blow. He fell into a profound depression, ceased his work, and felt that all hope was gone. But it was in this moment of despair that love appeared in the form of Jane Wilde, a student of languages. It was Jane who became the individual to restore Hawking's sense of direction. She gave him the inspiration to press on with his education, dedicate himself to science, and battle his illness. Their relationship provided the very bedrock upon which Stephen would construct the rest of his life. After resuming his research, Hawking's productivity began to surge, his focus captivated by a central question in cosmology. What transpires in the vicinity of a singularity in space and time? This is where he first confronted the full complexity of Einstein's general theory of relativity. Einstein had demonstrated that space and time are not a fixed stage, but can instead be distorted by matter and energy. Hawking took this concept even further, contemplating how these same principles must govern the universe as a whole. Collaborating with mathematician Roger Penrose, he developed the singularity theorem. Their finding was astounding. If general relativity holds true, then the universe itself must have started from a singularity, an instant where matter's density and spacetime's curvature become infinite. This breakthrough served as a powerful validation for the Big Bang Theory, effectively confirming that the cosmos had a definitive origin. And so, at a little over 20 years old, while contending with an illness that was progressively paralyzing his body, Hawking delivered one of the greatest scientific discoveries of the 20th century. He showed that cosmology was far more than philosophical musing. It was a precise science, capable of yielding exact mathematical solutions. As Stephen's physical strength gradually waned, his intellect journeyed to the highest peaks of science. He frequently noted that his condition compelled him to concentrate. Aware that his time was limited, he approached his work with an incredible fervor. This contradiction came to define his entire life. The more his body failed him, the more brilliantly his mind burned. By the mid-1960s, Hawking was already a significant presence in Cambridge, where his work was actively debated, and he began presenting at conferences. The scientific community was becoming acquainted with the name of the young physicist who had been given a terminal diagnosis instead of a future. He, however, chose the opposite path: to live and to make his mark on history. All the while, the disease continued its advance. Stephen soon required assistance to move and eventually relied on a wheelchair, but remarkably, this did not slow him down. A combination of inspiration, Jane's unwavering support, and a deepening fascination with cosmic mysteries only strengthened his resolve. These initial forays into science established the foundation for all his later discoveries, which would include not only his work on black holes and quantum gravity, but also worldwide recognition. It was right there, in Cambridge, amidst physical decline and profound uncertainty, that the resilience was forged that would transform him into an icon of science. By the close of the 1960s, Stephen Hawking's name was well established in scientific circles. His theorems on singularities, formulated with Roger Penrose, had a revolutionary impact. Their work demonstrated that if the universe adheres to the laws of general relativity, its beginning is not some mythological or philosophical concept, but a rigorous mathematical certainty. For many in the field, this represented the first major challenge to theories proposing an eternal universe. Hawking, however, was interested in more than just the birth of the cosmos. His attention was increasingly captured by black holes. These strange phenomena had been predicted by solutions to Einstein's equations, but had long been treated as theoretical curiosities rather than actual objects. Many astronomers even questioned if they could exist at all. Hawking resolved to apply the same disciplined methods to black holes that he had used for singularities. He started to examine their characteristics by posing simple yet profound questions. What occurs at the event horizon, the point of no return? Is information irretrievably lost when something falls into a black hole? And is a black hole truly black forever? His preliminary investigations revealed that black holes are not mere cosmic vacuums that consume everything in their path. Instead, they possess a strict, mathematically describable structure. One of his pivotal discoveries was that the surface area of a black hole's event horizon can never decrease. This property was strikingly similar to the laws of thermodynamics, where entropy, the measure of disorder, consistently increases. This insight would eventually lead Hawking to formulate the celebrated laws of black hole mechanics. Simultaneously, as the disease worsened, Hawking grew more reliant on his wheelchair. His speech became increasingly slurred, forcing colleagues to listen intently to catch his every word. Despite these challenges, the scientific world recognized it was engaging with a genius who could perceive what others missed. During this period, Hawking married Jane Wilde, and their union became not just a personal story, but a public symbol of his enduring fight. Jane assumed much of the burden of his care, and her support was what made it possible for him to continue his research. Toward the end of the 1960s, astronomers started gathering the first indirect proof of black holes. For instance, observations of the Cygnus X1 system revealed unusual X-ray emissions that could be explained by matter spiraling into a massive, invisible object. For Hawking and his fellow theorists, this was a moment of vindication, as their equations were beginning to align with observable reality. Stephen plunged even deeper into these investigations, understanding that black holes held the key to deciphering the fundamental nature of space and time. It was during this time that Hawking started to cultivate his distinctive method of working. He had a strong aversion to complex calculations, often stating that a single, elegant idea was more valuable than 100 pages of equations. His greatest asset was his intuition. He possessed a remarkable ability to see the essence of a problem and then apply precise mathematics to that core insight. This gift enabled him to achieve breakthroughs where others would get lost in the formal details. As the decade drew to a close, Stephen Hawking had firmly secured his position as one of the most prominent cosmologists of the era. His research was frequently referenced. He was a sought-after speaker at conferences, and his name was inextricably linked with pioneering concepts about the universe's origins and the essential nature of black holes. Yet, he was on the cusp of a discovery destined to transform physics and earn him renown far beyond the scientific community, as he would prove that black holes are not perfectly black, but actually radiate energy. In the early 1970s, Hawking was already a highly respected young scientist, but it was during this time that he made the discovery that would etch his name into the annals of science forever. He began to contemplate what might occur if the laws of quantum mechanics were applied to the description of a black hole, in addition to Einstein's general theory of relativity. This was a profoundly audacious move, as most physicists at the time steered clear of uniting these two theories due to their significant incompatibilities. Hawking, however, had a unique talent for posing questions that were both simple and deeply radical. He wondered whether a black hole was genuinely, absolutely black, or if considering quantum effects might reveal that it could, in fact, emit something. To understand his insight, it's helpful to explain what was happening at a fundamental level. According to quantum field theory, a vacuum is never truly void. Virtual particles and antiparticles continuously pop into existence and annihilate each other, and their fleeting presence has real consequences. Now, you can picture such a pair of particles appearing precisely at the edge of a black hole's event horizon. If one particle is pulled inside while its counterpart manages to escape, an observer from the outside would register this event as genuine radiation. This is exactly the phenomenon Stephen Hawking theorized in 1974. He demonstrated that black holes must emit a faint yet tangible radiation, which gradually causes them to lose mass and evaporate over immense timescales, an effect that would come to be known as Hawking radiation. This revelation was nothing short of revolutionary, as physicists had long operated under the assumption that black holes were eternal cosmic fixtures. Suddenly, Hawking's work suggested they possess a finite existence. The discovery seemed almost paradoxical at first. Objects thought to be the ultimate traps for matter and energy were now shown to be capable of losing mass and eventually disappearing entirely. Crucially, this conclusion stemmed not from speculation, but from exacting mathematical calculations. The idea generated a tremendous stir within the physics community. While some of Hawking's peers marveled at his intellectual courage, others remained skeptical, especially since the proposed radiation was far too faint to be detected by the telescopes of the day. But regardless of the ongoing debate, the very concept of this phenomenon fundamentally altered our comprehension of the interplay between quantum mechanics and gravity. The discovery's importance went beyond just revealing that black holes were mortal. It illuminated a profound link connecting quantum theory, thermodynamics, and gravity, uniting three disparate branches of physics into a single, cohesive framework. This achievement instantly catapulted the young scientist, already confined to a wheelchair, to international fame. proving he could surpass his contemporaries using only the sheer force of his intellect. Many colleagues remarked that he could formulate thoughts more rapidly than they could transcribe them. However, this breakthrough also introduced a complex new puzzle: the renowned information paradox. If a black hole completely evaporates, what becomes of the information concerning everything that ever fell into it? The principles of quantum mechanics dictate that information cannot be irrevocably destroyed. Yet, Hawking's own calculations indicated that during a black hole's evaporation, this information is indeed lost, a contradiction that would become one of modern physics' greatest enigmas and preoccupy scientists for decades. Despite his progressively worsening health and speech that became increasingly laborious to decipher, Stephen Hawking's intellectual brilliance only burned brighter. He held a professorship at Cambridge and grew into a symbol of science's power to overcome any physical limitation. Hawking radiation became his defining contribution, a phenomenon known even to those with little interest in physics, making its way into textbooks, lectures, and popular science books about the cosmos. While it has yet to be directly observed, its theoretical prediction alone has reshaped science. By the mid-1970s, Stephen Hawking was indisputably one of the world's leading physicists, a figure who didn't just contribute to scientific debates, but actively guided their course. His ideas formed the bedrock of a new cosmology, in which black holes were no longer viewed as cosmic dead ends, but rather as crucial keys to deciphering the fundamental structure of the universe. Yet, as his scientific celebrity grew, so did the advance of his illness. Amyotrophic lateral sclerosis, or ALS, was systematically draining his physical strength. He progressively lost the ability to use his hands, became completely reliant on a wheelchair, and found speaking to be an immense struggle. For almost anyone else, this would have spelled the end of a career in science. Hawking, however, was a person who consistently achieved the impossible, transforming his condition from a sentence into a source of motivation. He famously stated, "My disease took much from me, but it left the most important thing, my mind." This perspective became the cornerstone of his existence, and his wife, Jane, played a monumental role in his life. She shouldered the immense responsibility of caring for her husband and their children, cultivating a home environment where he could continue his intellectual pursuits. Jane would later confess that she was living at the very edge of human endurance, but her unwavering belief in her husband was what kept him from surrendering to his circumstances. Despite facing immense hardships, their family stood as a testament to resilience and love. A critical turning point arrived in 1985, when Stephen Hawking contracted a severe case of pneumonia. To save his life, doctors recommended a tracheotomy, a procedure that would result in the complete and permanent loss of his ability to speak. He consented, and from that day forward, he never uttered another word with his own voice, a reality that seemed destined to end his scientific career. After all, how could a theorist communicate his revolutionary ideas without being able to talk? But just as his physical voice fell silent, a marvel of technological innovation emerged to give him a new one. A team of engineers developed a custom computer speech synthesizer specifically for him. He first operated it using a finger, but as his condition progressed, he adapted to controlling it with the twitch of a cheek muscle. The resulting voice, with its distinct American accent, became his unmistakable trademark. Hawking often joked that even as more advanced technologies became available, he had no plans to change it, as it had become a part of his identity. This electronic voice enabled him to write articles, collaborate with colleagues, and deliver lectures, effectively restoring his ability to work. His public presentations transformed into legendary events. Entire auditoriums would sit in rapt silence as the metallic, synthesized voice delivered simple, yet profound statements about the cosmos, the nature of time, and the destiny of humanity. Though the illness made his existence incredibly challenging, it also paradoxically magnified his public image. Stephen became an icon of humanity's unwavering struggle against difficult circumstances, demonstrating to the world that the mind can remain boundless and potent even when the body fails. Many people who were far removed from the world of theoretical physics found themselves admiring his incredible strength of will more than his scientific theories. Throughout this period, Hawking's work ethic never faltered. He continued to attend conferences, publish papers, and refine his groundbreaking ideas on black holes and the universe's origins. His colleagues frequently commented on his astonishing level of focus. It seemed his illness had stripped away the capacity for trivial distractions, lending an incredible weight and clarity to every thought he formulated. It was also during this time that he began seriously considering the popularization of science. Hawking recognized the unique platform his life had given him, and felt a profound duty to share the grand ideas of cosmology with the widest possible audience, inspiring everyone to think about the stars, black holes, and our own place in the cosmos. In this way, the very disease that doctors had initially viewed as a terminal diagnosis became a powerful catalyst. Instead of stopping him, it fueled his resolve, making him more determined than ever. As his body grew progressively weaker, his ideas only gained more strength and influence. He outlived his initial prognosis not by a few years, but by decades filled with discovery and communication. This stark contrast between a frail body and a titanic intellect is what elevated Stephen Hawking into an almost mythical figure, proving that the power of the human spirit can indeed triumph over the cruelest of fates. By the end of the 1970s, Stephen Hawking was not just a distinguished scientist, but a globally recognized name, primarily within academic circles, for his discoveries about black holes and cosmic origins. Yet, he aspired to something more. He wanted the principles of cosmology to be accessible to everyone, not just a select group of theoretical physicists. This ambition was the seed from which grew a book that would fundamentally alter the course of his life. A Brief History of Time. The concept of writing a popular science book about the universe came to him during the 1980s. He grasped that while public fascination with space was immense, the complex language of scientific papers made the subject impenetrable for most people. His plan was both straightforward and audacious: to explain the most profound questions in cosmology in a way that anyone, regardless of their educational background, could comprehend. His driving motivation was a desire to show that the universe's greatest mysteries were within everyone's reach. Released in 1988, the book was an instant global bestseller, translated into dozens of languages and selling millions of copies. A truly phenomenal achievement for a work of scientific literature. Suddenly, people who had never considered a physics textbook were engrossed in reading about the Big Bang, black holes, and the curvature of space-time. The book's unique appeal stemmed first from Hawking's distinctive authorial voice, which made readers feel as if he were personally explaining these complex ideas to them. Secondly, he courageously tackled deep philosophical questions about why the universe exists, whether it had a beginning or an end, and if there is a place for God in this scientific worldview. A critical decision that made the book so accessible was his deliberate avoidance of complex mathematical formulas. He famously quipped that every equation included would have the book's readership, so he limited himself to just one: Einstein's celebrated E equals mc squared. Everything else was explained using clear language, vivid metaphors, and relatable examples. Interestingly, Hawking himself was astonished by the book's runaway success. He had anticipated some interest from students and fellow scientists, but never imagined it would become a cultural phenomenon, purchased in airports and read by people on vacation. Beneath this incredible success, however, lay a story of profound personal struggle. At the time of writing, Hawking was already completely paralyzed, able to compose the text only through his computer interface. The process demanded an extraordinary level of effort, with his assistants noting that it could sometimes take weeks to craft just a few paragraphs. Yet this intense labor imbued the text with a rare depth. Every sentence was the product of immense concentration. A brief history of time brought him a new kind of fame, elevating him to the status of a true scientific celebrity, comparable to a rock star or a film actor. It is vital to recognize the book's enormous role in popularizing science for a new era. It sparked an interest in the cosmos among millions of ordinary people, and inspired an entire generation to pursue careers in physics and astronomy. In this respect, Hawking's contribution through this one book may ultimately be viewed as even more impactful than his many specialized scientific papers. It was a gift that opened up the universe to all of us. Stephen Hawking declared his life's purpose was to understand the mind of God, a phrase he used to describe the fundamental laws governing our universe. His celebrated book became a crucial step in this pursuit, not only for his own understanding but for humanity as a whole. Consequently, by the close of the 1970s, Hawking had become a global symbol for science itself. His distinct voice, groundbreaking ideas, and influential book elevated him from the status of a mere scientist to that of an enduring legend. The publication of A Brief History of Time irrevocably altered the course of Stephen Hawking's life. Where he had once been recognized only within the confined world of academia, he was now known to people everywhere. He transformed into an emblem of both scientific genius and immense courage, a figure who could articulate the mysteries of the cosmos in a manner that captivated physicists, school children, and even those who had never before given science a second thought. This newfound fame opened up the world of popular culture to him, leading to invitations for television shows and documentary appearances. He began giving interviews to major newspapers and magazines, making the image of a scientist in a wheelchair with a synthetic voice an instantly recognizable one around the world. There was a unique power each time his computer spoke about the cosmos. Audiences were moved by the juxtaposition of a cold, electronic sound conveying thoughts of incredible profundity. His lectures consistently drew massive crowds, and entire auditoriums would fall silent as that metallic voice explained the universe's origins, or the concept of evaporating black holes. For many attendees, these events were nothing short of revelatory, as Hawking possessed a rare talent for distilling complex theories into simple, powerful truths. That you and I inhabit an astonishing world brimming with mysteries that we have the capacity to solve. He frequently stated that science's primary mission should be to make the cosmos more accessible to everyone. His speeches were never bogged down by complex equations. Instead, he communicated through powerful imagery and metaphors. For instance, He famously depicted the universe as a vast book whose pages we have only just started to read, a language that was universally understood and appreciated. This approach helped him become more than just a scientist. He evolved into a cultural phenomenon. He received invitations to appear in television series and even animated shows, making cameos in The Simpsons and Futurama, and portraying himself in The Big Bang Theory. It was an unprecedented situation. A serious scientist becoming an integral part of mass culture without ever compromising his dedication to rigorous research. Interestingly, Hawking himself viewed this fame with a sense of irony, recognizing that while his image was being used by the media, it ultimately served the greater good of popularizing science. However, this widespread recognition came with its own set of challenges. As his illness advanced, the effort required for his care became immense, and his family life faced significant strain. Yet, to the public, the prevailing image was one of unblemished triumph. A brilliant mind, physically confined, who had become the voice of science for millions of people. His international travels were particularly remarkable, as he was welcomed as a hero in the United States, Japan, and China, meeting with world leaders and other eminent scientists. During this period, he continued his research, publishing new scientific papers that explored quantum cosmology and the information paradox. Increasingly, though, his work became intertwined with the popularization of science. He authored more books for a general audience, collaborated on documentaries, and worked tirelessly to inspire a new generation to enter scientific fields, cementing his legacy as a scientist educator who bridged the gap between fundamental physics and the public. Throughout the 1980s and early 1990s, Stephen Hawking turned his attention to an even more profound question. How did the universe itself begin? While his singularity theorems suggested a definite starting point, they left open the much deeper mystery of what precisely occurred at the moment time itself was born. In collaboration with American physicist James Hartle, he developed what became known as the no-boundary proposal. This model was audacious and, on the surface, seemed almost paradoxical. Hawking proposed that if you combine the laws of quantum mechanics and gravity, the universe could have emerged without an initial singularity. He suggested that at its inception, time was closed, much like the surface of a sphere. To visualize this, think of a globe. It has no edges or starting point. No matter which direction you travel, you will never fall off the end. According to the Hawking-Hartle hypothesis, time at the universe's beginning was similarly rounded, rendering the question of what existed before the Big Bang entirely moot. This groundbreaking idea ignited intense debate within the scientific community. Some physicists hailed it as a truly elegant resolution to the problem of the universe's origin, while others criticized it as an overly speculative interpretation of quantum mechanics. Regardless of the controversy, the hypothesis became a cornerstone of modern cosmology, as it framed the birth of our world not as a singular mysterious act of creation, but as a natural process dictated by the laws of physics. For Hawking, this work was a direct extension of his ultimate goal, to demonstrate that the universe could be explained without invoking supernatural intervention. While his stance didn't explicitly deny faith, it underscored his belief that physics possesses the tools to answer our deepest questions about the cosmos. The no-boundary proposal was a crucial step toward a theory of everything, a unified set of equations that could describe all natural phenomena, and a theme he would continue to explore in his books and lectures for years to come. He helped people understand that the cosmos isn't merely the expanse of stars, but the very texture of time itself, which might have once been compressed into an infinitesimally tiny point. Consequently, when you study cosmology, you are searching for insights not just into stars, but into the origin of all existence. This hypothesis significantly elevated his renown, earning him a reputation in the scientific community as someone unafraid to confront the most formidable questions. To the public, he became a philosopher in a wheelchair, articulating that the universe lacks boundaries and, possibly, a beginning, in the way we typically conceive of it. During the 1990s, Stephen Hawking cemented his position as the foremost cosmologist of our era. Beyond making groundbreaking discoveries, he offered humanity an entirely new framework for understanding the nature of time itself. While his no-boundary proposal sparked intense discussion within scientific circles, Hawking turned his attention to another challenge that would become a true enigma for late 20th century physics: the well-known information paradox. The paradox itself is straightforward to articulate, but presents immense complexity for scientific resolution. According to the principles of quantum mechanics, information regarding the state of particles can never be permanently erased. While it might transform, scatter, or become unobservable, it cannot be utterly destroyed. This is a foundational law. Yet Hawking's own theory on black hole radiation suggested precisely the opposite outcome. If a black hole completely evaporates, then everything that has ever been drawn into it, from stars and planets to light and matter, vanishes without a trace. This implies that all information tied to those objects is wiped from existence, a direct violation of the tenets of quantum mechanics. This created a stark choice. Either quantum theory needed revision, or our comprehension of black holes was fundamentally flawed. This paradox swiftly grew into one of the most urgent problems in physics. For many decades, scientists passionately argued over whether information could be preserved or if black holes did indeed obliterate it. For a long time, Hawking himself championed the view that information is irretrievably lost, publishing articles, speaking at conferences, and debating with his peers to prove that a black hole's evaporation signifies the ultimate end for any information it consumed. His firm stance was a source of frustration for many physicists, including esteemed figures like John Preskill and Leonard Susskind, who felt that the laws of quantum mechanics were too fundamental to be so easily broken. In the 1990s, these discussions escalated into a full-scale scientific confrontation. Preskill and Susskind challenged Hawking in academic papers and public forums, but Hawking steadfastly held his ground, even wagering that if information was proven to be conserved, he would concede defeat by gifting his opponents a book about baseball. These intellectual clashes became the stuff of legend, allowing the public a rare glimpse of the world's brightest minds debating not minor details, but the very cornerstones of physics. There was a poignant symbolism in this dynamic. While Hawking's body was limited by his illness, his intellect remained at the very epicenter of scientific revolution. Crucially, the information paradox ultimately proved to be a catalyst for scientific advancement, compelling researchers to develop new theories that could reconcile quantum mechanics with gravity and fostering the growth of fields like string theory and the holographic principle. Eventually, Hawking himself revised his position on the matter. In 2004, at a conference in Dublin, he publicly admitted that information likely does not disappear, but is preserved in some form. In a historic moment of scientific integrity, he conceded the debate and presented John Preskill with the promised book, demonstrating that even the most brilliant intellect must yield when confronted with contradictory evidence. Nevertheless, a definitive solution to this problem has yet to be found. The information paradox remains a central puzzle in modern physics, its enduring value lying in its power to inspire future generations of scientists to continue the search for answers. For Hawking, this paradox was a cornerstone of his legacy, showing that science is driven not just by solutions, but by profound questions that push humanity forward. While the scientific community was engrossed in debates over the information paradox and the no-boundary universe, Stephen Hawking's personal life was marked by its own dramatic developments. As his illness advanced, his care demanded ever more support, with his wife, Jane, serving as his unwavering pillar. She had stood by him for years, assisting with every need while they raised their 3 children, and attempted to lead as normal a life as they could under the circumstances. Jane would later reflect that although their home was filled with laughter and love, an immense strain lay just beneath the surface. By the late 1970s, their relationship was under severe pressure. Hawking's increasing physical dependence and his global celebrity transformed him into a public figure constantly surrounded by aides, reporters, and students, leaving Jane feeling isolated and exhausted. It was during this time that a musician, Jonathan Hellyer Jones, entered their lives to help the family, and a close bond formed between him and Jane. In the 1990s, Hawking entered into a new relationship with his nurse, Elaine Mason, a union that ignited considerable public discussion. It was viewed by some as a tale of love and dedication, while others saw it as a deeply troubled drama. Allegations surfaced in the media accusing Elaine of being excessively controlling, with rumors of abuse even circulating, though these were never officially substantiated. For his part, Hawking consistently denied any such claims. In 1995, Stephen Hawking formally divorced Jane and went on to marry Elaine. That marriage would continue until 2006, at which point they went their separate ways. Despite the end of this relationship, Hawking stayed connected with his children and later re-established a friendship with Jane. These family experiences demonstrate that his life was far more than a sequence of scientific breakthroughs. He contended with the same challenges many people face, including the search for love, marital troubles, disagreements, and reconciliations, which perhaps made him more relatable to the public. He was a genius, but he was also undeniably human. You have to recognize the profound impact his illness had on his personal life. Caring for him demanded not just patience, but a complete and total dedication from those around him. His family and partners were under constant strain, navigating a complex reality where admiration for his intellect coexisted with profound exhaustion. Theirs was a life lived at the very boundary of human capacity. Yet through it all, Hawking consistently aimed for optimism, readily joking about himself, sharing anecdotes, and taking part in public events. Even amid personal crises, he maintained an extraordinary sense of humor, and his children have recalled how their father's passion for life never faded, allowing him to find laughter in even the most trying of times. Ultimately, Stephen Hawking's private life is a narrative of immense trials, affecting not only him, but everyone close to him. While his genius was a brilliant beacon in the world of science, its light was always accompanied by the shadow of personal dramas. He often declared that his foremost scientific ambition was the pursuit of a theory of everything, a single, unified formula that could account for all the laws governing the universe. He held a firm belief that humanity was capable of discovering equations that would merge quantum mechanics with general relativity, enabling us to understand not just how the cosmos functions, but why it exists at all. The core of the problem lay in the fact that the two greatest theories of the 20th century were fundamentally incompatible. Einstein's general theory of relativity masterfully explained the macrocosmic world of planets, stars, and galaxies by describing how mass and energy warp spacetime. However, it failed at the microscopic scale, where the probabilistic and uncertain world of quantum mechanics held sway. Conversely, quantum theory perfectly described the behavior of elementary particles, but fell apart when applied to the force of gravity. Hawking treated this dissonance as a call to action, convinced that nature is ultimately unified and that its laws cannot be self-contradictory. To work toward a resolution, he pioneered the field of quantum cosmology, which seeks to apply quantum principles to describe the entire universe. His no-boundary proposal, which he developed alongside James Hartle, represented a major step in that direction. Throughout the 1980s and 90s, a growing number of physicists were captivated by string theory, a concept that promised to unify all of nature's forces by proposing that elementary particles are not points, but rather tiny vibrating strings. While mathematically beautiful, string theory lacked any means of experimental verification. Hawking followed its evolution with keen interest, yet he never viewed it as the ultimate explanation. For Hawking, the most critical aspect was that humanity had reached a threshold leading to an understanding of the universe's deepest structure. He was convinced that we might one day find a single formula to explain everything, from the motion of planets to the behavior of quanta, a moment he famously said would be like knowing the mind of God. This concept fascinated the public as much as it did scientists. During his lectures, he was frequently asked if we would truly one day understand everything. His response was always measured. While possible, the path to that knowledge would be long and exceptionally difficult, as nature itself could prove to be far more complex than we imagine. In his books and articles, Hawking argued that the search for a theory of everything was not merely a scientific objective, but also a profound philosophical question. If we were to uncover all the laws of the universe, would we then grasp its meaning? Or would that meaning forever lie beyond the reach of equations? Such reflections established him not only as a physicist, but as a philosopher of science. Crucially, he never limited himself to academic circles. He possessed a unique gift for explaining complex ideas in a way that anyone could grasp, often using powerful imagery, such as comparing his quest to finding the final piece of a puzzle, or hearing a grand symphony in its entirety after only knowing fragments. Following the phenomenal success of A Brief History of Time, Stephen Hawking recognized that his purpose now extended well beyond the confines of academic science. He became a true popularizer, a figure who could articulate the most challenging ideas in cosmology using simple, accessible terms, drawing in millions of ordinary people alongside specialists. In the early 1990s, he published Black Holes and Baby Universes and Other Essays, a collection that both elaborated on his scientific theories and shared his personal reflections. This was followed by The Universe in a Nutshell, a vibrant and heavily illustrated book that served as a bolder, more immersive sequel, guiding readers through the newest frontiers of science, including string theory, supersymmetry, and the multiverse hypothesis. This search for a unified theory became the defining symbol of his scientific journey. He committed decades of his life to this work, and even though a conclusive answer was never reached, The process of inquiry itself opened up entirely new horizons for physics. It is thanks to scientists like Hawking that humanity has moved closer to understanding the fundamental laws of nature. And when he spoke of the potential impossibility of a complete theory, acknowledging that new mysteries may always lie ahead, it never came across as a note of defeat. For him, it simply meant that humankind would always have a purpose, an eternal drive to peer beyond the known horizon. Stephen Hawking possessed a remarkable talent for crafting books that were as much philosophical explorations as they were scientific treatises. He delved into the fundamental nature of time, considered the feasibility of time travel, and explored the concept of a universe existing without a creator. These profound thoughts sparked the imagination of his readers, encouraging them to engage in debate and search for their own understanding of the cosmos. Among his extensive body of work, the books co-authored with his daughter, Lucy Hawking, hold a special significance. This collection of science adventure stories for children, including titles like George's Secret Key to the Universe and George's Cosmic Treasure Hunt, presented complex topics such as black holes, planets, and the laws of physics in a captivating and accessible manner. Through these narratives, Hawking connected with the youngest generation, cultivating a fascination with the universe from an early age, knowing that the future of science hinges on inspiring young minds to question the world around them. Beyond his books, Hawking was also a prominent figure in the creation of television documentaries. The acclaimed series Into the Universe with Stephen Hawking is a prime example, in which he discussed the origins of the universe, the mysteries of black holes, and the potential for extraterrestrial life. These films made his synthesized voice instantly recognizable to millions of viewers worldwide. It's crucial to understand that for Hawking, these popularization efforts were not a secondary pursuit, but a mission of immense personal importance, driven by his desire for every individual, regardless of their educational background, to feel a connection to the great mysteries of the universe. By the early 2000s, Stephen Hawking had evolved from a renowned scientist into a global cultural phenomenon. His books achieved sales in the millions. His lectures attracted vast audiences. And his iconic image, a man in a wheelchair communicating about the stars through an electronic voice, came to symbolize humanity's relentless pursuit of knowledge. Throughout his entire life, Hawking was captivated by the essence of time. And his groundbreaking work on black holes and the universe's origin naturally led him to profound questions. What exactly is time? Why does it seem to flow in only one direction? And could we ever travel into the past or the future? He frequently explained that time is not some absolute, unchanging entity, but rather another dimension, much like the three dimensions of space. Drawing from Einstein's theory of relativity, he illustrated how time is relative, flowing at different rates for different observers. It slows down as you approach the speed of light and warps under the influence of strong gravity. In his books, Hawking also explored the theoretical possibility of time travel, noting that general relativity permits mathematical solutions known as closed time-like curves, paths through space-time that could theoretically allow an object to journey into its own past. While these models were plausible on paper, Hawking treated the idea with a healthy dose of skepticism and a touch of humor. He proposed a concept he called the chronology protection hypothesis, which suggests that the laws of physics might inherently prevent travel into the past to avert logical paradoxes. After all, he reasoned, if it were possible, we would likely have already met visitors from the future. This led to his famous jest, "I once threw a party for time travelers, but no one came." In contrast, he viewed travel to the future as far more realistic, as it is a consequence already built into the laws of physics. According to relativity, an astronaut traveling at nearly the speed of light would experience time much more slowly than people on Earth, effectively arriving in our distant future upon their return. Hawking enjoyed speculating about how humanity might one day harness such phenomena, perhaps by creating wormholes, theoretical tunnels through spacetime that could link different locations in the cosmos, or even different eras. His reflections on time consistently transcended pure science, venturing into the realm of philosophy. He proposed that understanding the nature of time is inextricably linked to understanding the meaning of our own lives. Whether the universe has a definitive beginning and end, or is part of an eternal cycle, our existence is framed within that grand narrative. It was this powerful fusion of physics and philosophy that drew a vast readership to his work, connecting not just with scientists, but with anyone who has ever contemplated the meaning of existence. Among the most daring concepts Stephen Hawking championed was the multiverse hypothesis, which he saw as a potential solution to the question of why our world is structured exactly as it is. The core of this idea is that our universe might be merely one of an infinite number of parallel worlds. Each of these universes would possess its own distinct physical laws, fundamental constants, and overall structure. In some, stars and planets might form, while in others they would be impossible. In some, matter might behave as we know it, while elsewhere the laws of physics would be utterly alien to us. This concept is crucial because it offers a compelling answer to why the laws of our particular universe seem so perfectly calibrated for the emergence of life. If an infinite number of universes exist, each with a random set of rules, it is statistically inevitable that at least one, our own, would happen to have the right conditions for life to arise. This line of reasoning is known as the anthropic principle. We observe the universe to be this way simply because if it were any different, we wouldn't be here to observe it. Hawking saw the multiverse as a way to remove the mystery from this apparent fine-tuning, reframing our existence not as a miracle, but as a natural outcome within a vast cosmic landscape of possibilities. This concept also introduced fresh perspectives into the field of cosmology. If the multiverse is a reality, then its study could illuminate not only our own universe, but also the fundamental laws that govern all conceivable worlds. Stephen Hawking frequently asserted that the multiverse hypothesis was more than mere speculation. He considered it a legitimate scientific concept capable of resolving many puzzles in modern physics. He also conceded, however, that the idea of the multiverse introduces its own set of challenges. For instance, if an infinite number of universes exist, how could we ever realistically hope to comprehend or detect them? Hawking proposed that even without direct observation, their presence could be deduced from the physical laws that operate within our own cosmos. This made the multiverse hypothesis another audacious stride in Hawking's scientific career, pushing the boundaries of cosmology and encouraging scientists to look beyond our immediate reality. For Hawking, the multiverse was not merely a theoretical exercise. It represented a pathway to investigating the most profound questions about existence and our role within it. For example, if constants like the force of gravity or the electron's charge were altered by even a tiny fraction, stars could never form, planets would not coalesce, and life as we know it would be impossible. Many scientists interpreted this as a form of cosmic fine-tuning that bordered on the miraculous. The multiverse, a theoretical collection of all possible universes, elegantly resolves this dilemma. With an infinite number of worlds, it is hardly surprising that in at least one, the physical laws would be perfectly suited for life. We find ourselves in this specific universe precisely because it is one of the few that permits observers to evolve. This concept is known as the anthropic principle, a tool Hawking often employed in his writings. Naturally, the idea of a multiverse ignited significant debate. Critics contended that if other universes are fundamentally unobservable, the concept belongs to philosophy, not science. Hawking countered that such hypotheses could still be tested indirectly, for instance, by analyzing the cosmic microwave background, the relic radiation pervading the universe, or by studying the distinct properties of black holes. To the general public, this notion sounded like something out of science fiction, which was a major part of its appeal. People were captivated by the thought of other worlds where life follows different rules, and entirely different civilizations might exist. Hawking possessed a unique talent for framing these complex ideas in a way that transformed them from abstract theories into compelling reasons to contemplate humanity's cosmic significance. Crucially, the multiverse hypothesis dovetailed perfectly with his concept of a universe with no beginning boundary. If the universe could emerge from quantum fluctuations, then what would prevent an infinite number of such creative flashes? From this vantage point, the cosmos is not a single entity, but rather a vast ocean composed of innumerable worlds, a concept that presented both a scientific and a philosophical challenge. Hawking saw that if countless other universes exist, it forces us to ask about the importance of our own. Does the value of our world diminish in such a grand scheme, or does the uniqueness of each individual life become even more profound? He intentionally left these questions unanswered, inviting you, the reader, to find your own conclusions. The multiverse thus stands as one of the most mesmerizing and contentious parts of his legacy, bridging the gap between rigorous physics and human imagination. Stephen Hawking was more than a theorist of black holes and cosmic origins. He was also a thinker who frequently reflected on the future of our species and the potential for extraterrestrial life. In his lectures and books, he approached these subjects not as a writer of fiction, but as a scientist exploring various potential paths for civilization. He consistently argued that the odds of other life forms existing in the universe are exceptionally high. His reasoning was straightforward. The cosmos is incomprehensibly vast. Our own galaxy, the Milky Way, is home to hundreds of billions of stars, a great many of which are orbited by planets. It would be statistically peculiar, he argued, to presume that life has arisen on only one tiny planet, our Earth. Yet, when considering the nature of alien civilizations, Hawking expressed a great deal of caution and even a degree of skepticism. He warned that making contact with a highly advanced civilization could pose a significant danger to humanity. He often drew an analogy to the history of European expansion, where encounters between technologically superior and less developed peoples almost invariably resulted in tragedy for the latter. He once remarked that if aliens were to visit Earth, the consequences might mirror what befell the Native Americans following the arrival of Columbus. Despite these grave warnings, he was a firm supporter of projects searching for extraterrestrial signals, such as SETI, the Search for Extraterrestrial Intelligence. In 2015, he even joined the Breakthrough Listen initiative, a project bankrolled by billionaire Yuri Milner, which utilizes the world's most powerful radio telescopes for an extensive hunt for signals from alien civilizations. Hawking stressed that even if we never find direct proof, The search itself deepens our understanding of the universe. His perspective on aliens was curiously divided. While he believed in the high probability of their existence, he also felt it would be wiser for humanity to avoid drawing attention to itself on a cosmic scale. As he put it, we are simply not prepared to encounter a civilization more powerful than our own. For the public, his words were a source of both excitement and unease, challenging the common fantasy of friendly extraterrestrials and forcing people to consider the potential risks. Ultimately, his ideas served as a powerful reminder that while space is a realm filled with wonder, it is also a domain that harbors unknown dangers. This ability to expand our horizons and compel us to view the cosmos in a new light was the true essence of Stephen Hawking's strength. Furthermore, he spoke at length about humanity's destiny as a species that travels among the stars. He argued that our civilization's survival depends on colonizing other worlds, as Earth would ultimately prove too delicate a cradle for humanity. He identified several dangers, including climate change, nuclear conflict, pandemics, and asteroid strikes, all of which place Earth's long-term viability in question. Hawking advocated for looking toward the future and preparing for a migration to different planets. He was convinced that over the next few centuries, humanity must build settlements on the Moon and Mars before venturing out to the stars. In his mind, this was not a fanciful dream but a crucial requirement for the continuation of our species. His reflections on extraterrestrial life and humanity's fate thus blended scientific data, philosophical inquiry, and a stern warning, inspiring cosmic dreams while teaching caution. Stephen Hawking consistently underlined that for humanity to have a long-term future, it must depart from Earth. These statements were not dramatic flourishes, but were founded on cool scientific analysis. From his perspective, our homeworld is excessively vulnerable, with our existence hanging on a delicate balance of climate, resources, and global threats that could shift the course of history without warning. He warned that civilization faces potential annihilation from nuclear war, devastating climate change, a worldwide pandemic, or the impact of an asteroid. Although the individual probability of each disaster is small, their cumulative risk makes humanity's reliance on a single planet an exceedingly dangerous gamble. For this reason, Hawking urged the establishment of colonies beyond our home world. He initially proposed the Moon and Mars as primary targets for settlement. The Moon, in his estimation, could function as the first outpost, a sort of launching point for deeper space exploration. Its close proximity to Earth makes it a convenient laboratory for experimenting with the construction of self-sufficient bases. Mars, however, he viewed as the more viable long-term prospect, as it possesses a thin atmosphere, distinct seasons, and even water reserves in the form of ice. Hawking believed that within the next 100 years, humanity must create permanent habitations on Mars. This would serve not only as a landmark scientific achievement, but also as a vital insurance policy in the event of a global catastrophe on Earth. By having a second home, humanity could endure even the most severe calamities. He insisted that the colonization of other planets was a question of when, not if, and that the sooner we started, the better our chances of survival would be. His ideas encouraged people to adopt a grander perspective, to look beyond their immediate surroundings, and to envision space as a new frontier. Interestingly, his concepts aligned with the renewed enthusiasm for space missions in the 2000s and 2010s, which saw the emergence of private enterprises like SpaceX that openly stated their goals of colonizing Mars. Many interpreted this as the realization of the very dreams Hawking had described. However, he was fully aware that settling on other planets presents an extraordinarily complex challenge. We would need to engineer closed-loop ecosystems, overcome the dangers of cosmic radiation, and devise methods for producing food and energy under extreme conditions. Far from being naive, he saw these obstacles as a powerful driver for advancing science and technology. Beyond the practicalities, Hawking also emphasized a significant psychological component. He believed that humanity needs to shift its focus away from its internal disputes and conflicts. The shared goal of space exploration has the power to unite people, prompting them to contemplate the future rather than their immediate disagreements. In this sense, colonizing other worlds is not merely a survival strategy but a catalyst for elevating civilization to its next evolutionary stage. Thus, Hawking's proposals for colonies on the Moon and Mars evolved beyond mere scientific forecasts. They became a powerful statement of hope and a call to responsibility, demonstrating that humanity has a future beyond Earth if we possess the courage to build it. He was not just an optimist urging us to reach for the stars, but also a realist who soberly assessed the threats confronting our civilization. He frequently described the 21st century as a critical juncture. Humanity would either discover a way to endure and expand its presence beyond Earth, or face the possibility of self-destruction. One of the principal dangers he identified was nuclear weaponry. Created as a deterrent, these arms have always posed the risk of a global conflict sparked by accident or political instability. Another threat he perceived was climate change. The scientist remarked that humanity is far too reckless with its planet. He warned that greenhouse gas emissions, the destruction of ecosystems, and widespread pollution could render Earth increasingly inhospitable. He often pointed to Venus, where a runaway greenhouse effect has resulted in surface temperatures of 460 degrees Celsius, as a cautionary tale. Hawking also addressed the peril of global pandemics. Long before recent outbreaks, he observed that in a highly interconnected world where people travel constantly, diseases can propagate faster than ever before. He considered pandemics to be among the most realistic threats to our civilization. Asteroids were another source of concern for him. He reminded us that 65 million years ago, a massive asteroid impact caused the extinction of the dinosaurs, proving that such an event could certainly happen again. He gave special consideration to the rise of artificial intelligence. While he acknowledged its tremendous potential, he also feared it could spiral beyond human control. He famously stated, "The creation of full artificial intelligence could be either the greatest event in human history or the last." If machines were to acquire the capacity for self-improvement, he cautioned, humanity would be at risk of losing authority over its own destiny. Stephen Hawking was not an alarmist predicting inevitable ruin, but rather a pragmatist who called for deliberate preparation. He held the firm conviction that humanity must acknowledge emergent risks and act decisively by fostering international cooperation, overseeing technological progress, safeguarding our planet, and pursuing space exploration. His admonitions were not bleak prophecies, but were instead grounded in sober analysis, aimed at making people realize that the future hinges on the choices we make today. We stand at a crossroads where we can either orchestrate our own demise, or, with wisdom, construct a magnificent civilization, which is why Hawking emerged as a leading voice of caution, prompting many to treat these potential threats with newfound gravity. He was far more than a physicist. He was a philosopher committed to protecting the future of the human species. While Stephen Hawking was fundamentally a man of science, his focus extended beyond cosmology and black holes to contemplate humanity's role within the universe, and his pronouncements conveyed a distinct cosmic philosophy. For him, investigating stars and singularities was not merely a scientific endeavor, but a method for deciphering the meaning of human existence. Hawking often noted that the cosmos simultaneously highlights our insignificance and our greatness. Though we are a minuscule element in a universe that began 13.8 billion years ago, we are the ones capable of questioning its fabric, observing the heavens, and formulating theories, a capacity he saw as uniquely human. Despite our physical vulnerability, we are endowed with minds that can grasp the infinite. He frequently argued that science and philosophy should not be viewed as adversaries, explaining that science addresses the question of how the world functions, whereas philosophy helps us explore why. In his writings, Hawking acknowledged that he did not subscribe to the idea of a traditional God overseeing the cosmos, but he never dismissed the value of spiritual inquiry. For him, the quest for a theory of everything was a profoundly spiritual experience, an attempt to understand the inherent design encoded within the laws of nature itself. A central tenet of his philosophy was an unwavering faith in human progress, viewing our innate drive to ask questions, discover answers, and venture into the unknown as proof of our ability to conquer any obstacle. His own life, defined by illness, scientific breakthroughs, and personal challenges, stood as a powerful testament to this conviction, demonstrating that the human spirit can triumph over seemingly impossible odds. Hawking's philosophy was not solely about comprehending the universe, but about motivating humanity to aim for the stars, in both a literal and a figurative sense. He left a legacy that transcends science by reminding us that we belong to something immense and beautiful, and that our greatest assets in unraveling life's mysteries are our intelligence and curiosity. Stephen Hawking was convinced that humanity could surmount its difficulties by harnessing the power of reason and science. For him, the cosmos represented not just a place of enigma, but a wellspring of hope. He famously advised, "Look up at the stars and not down at your feet," a phrase that became his personal creed. This sentiment was a call to aspire to greater achievements, to avoid getting mired in everyday troubles, and to remember our place within a vast and wondrous world. His philosophy also incorporated a deep humility before the majesty of nature, as he admitted that we might never uncover all the answers. Yet he believed the journey of seeking them is what makes us truly remarkable, once saying, "We are just an advanced breed of monkeys on a minor planet of a very average star. But we can understand the universe. That makes us something very special." Crucially, Hawking perceived science not as an exclusive club for the intellectual elite, but as the common heritage of all humankind. He asserted that every individual has a right to grasp the fundamental principles of the cosmos, which is why he dedicated himself to writing books for a broad audience. In his worldview, scientific knowledge was not a secret to be guarded, but a light meant to guide the way for everyone. These principles established him as an exceptional figure, not just a scientist, but a sage who imparted a powerful message to humanity. The universe is vast, but you possess the power to understand it, and therein lies the meaning of your life. Despite the severity of his illness and the profound nature of his scientific inquiries, Stephen Hawking consistently maintained a sense of humor that both astonished and motivated countless people. That a man confined to a wheelchair, unable to speak on his own, could readily laugh and poke fun at himself and the absurdity of his condition revealed an inner strength. His humor was more than a character trait. It was a core part of his resilience. He frequently employed irony to diffuse tension, once quipping, when asked about his illness, that he didn't like moving around much anyway. His iconic speech synthesizer, with its mechanical tone and American accent, evolved into an effective vehicle for dry wit and clever jokes that resonated long after they were told. In the realm of popular culture, Hawking made memorable appearances in unexpected places, voicing himself in The Simpsons to playfully satirize the image of the omniscient scientist. He also featured in Futurama as part of a time-traveling team and made a cameo in The Big Bang Theory that became a series highlight, where he humorously interacted with other brilliant minds. These roles demonstrated that he was entirely unafraid to be a star in the most unconventional sense. Even during his most serious academic lectures, he would skillfully insert witty remarks to keep his audience engaged. He might be discussing the intricacies of black holes, and then casually add, "They're a lot like accountants, always hiding something." While his jokes were often simple, they possessed a certain lightness that made the complexities of cosmology feel more accessible. Friends and colleagues fondly remembered his capacity to laugh at his own fate, observing that his illness never broke his spirit, but instead seemed to sharpen his sense of irony. He often said that life would be far too difficult without humor, and it was this powerful optimism that fueled his continued work when many others would have surrendered. In this way, Hawking's humor became a vital channel for connecting with the world. He spoke with great deliberation, as each sentence required significant time and effort to form. Yet when a lengthy silence gave way to a brief, witty remark, the impact was magnified, drawing quiet anticipation from his audience, followed by heartfelt, roaring laughter. This unique quality extended to his perspective on the future. He would address grave dangers to humanity, such as nuclear war, pandemics, or artificial intelligence, not to incite fear, but to inspire a collective resolve to take action. This talent for weaving together gravity and humor set him apart, revealing him as more than just a brilliant scientist and philosopher. He was a person who possessed an extraordinary capacity to find light in the bleakest of situations. His witticisms and ironic observations became an essential component of his legacy, standing just as tall as his groundbreaking books and theories. They served as a powerful reminder that even the most formidable intellect remains human, and that the ability to laugh is vital. Stephen Hawking's life was defined by far more than his discoveries and publications. It was also marked by widespread global acclaim for his contributions to science. Though a Nobel Prize eluded him, his influence was celebrated with the field's most esteemed honors, making his name interchangeable with scientific genius. At the remarkably young age of 32, in 1974, he was elected a Fellow of the Royal Society of London, one of the world's oldest and most revered scientific bodies. Just 5 years later, in 1979, he was appointed the Lucasian Professor of Mathematics at Cambridge, a position famously occupied by Isaac Newton in the 17th century, symbolizing a passing of the torch between titans of science. His career was subsequently decorated with countless accolades, including the Albert Einstein Medal, the Gold Medal of the Royal Astronomical Society, and the Wolf Prize in Physics. He earned respect not just for his scientific breakthroughs, but also for his rare talent in bridging the gap between complex science and the public. This global recognition was epitomized in 2009 when Barack Obama awarded him the Presidential Medal of Freedom, one of America's highest civilian honors. The moment acknowledged not only the brilliant scientist, but also the man whose life story became an inspiration for millions worldwide. It is noteworthy that Hawking regarded his many awards with a characteristic touch of irony. The reason he never received a Nobel was straightforward. His most famous discoveries, like Hawking radiation, had not yet been confirmed by experiment, which is a prerequisite for the Nobel Committee. However, he never considered this a shortcoming. For Hawking, the true measure of success was whether his ideas were pushing the frontiers of science forward, a contribution he valued far more than any single prize. His fame ultimately transcended the confines of academia, as his public image evolved into a powerful symbol of intellect and resilience. He met with world leaders, became the subject of countless documentaries, and emerged as a genuine scientific celebrity. In this sense, the awards and honors merely formalized a status he had already achieved, that of a living legend. His name was recognized in every corner of the globe, his quotes appeared on posters, and his books found a place on the shelves of everyone from students to heads of state. Beyond being a world-class scientist, Stephen Hawking ascended to the status of a cultural icon, his fame reaching far beyond universities and into the very heart of popular culture. It is exceptionally rare for a theoretical physicist to achieve the kind of recognition typically reserved for actors or athletes. Yet his iconic image, a figure in a wheelchair communicating through a synthesizer about cosmic mysteries, came to define an era. He made memorable appearances in beloved television shows, starring as a comically exaggerated version of himself in The Simpsons, and even playing himself on The Big Bang Theory, where he playfully critiqued the main character's work. These television roles endeared him to a broader audience and demonstrated his willingness to engage with mainstream entertainment. His synthesized voice achieved global recognition, its distinctive metallic tone becoming synonymous with the cosmos itself. Despite technological advancements offering alternatives, he deliberately retained this voice, explaining that it had become his personal trademark. Documentaries like Into the Universe with Stephen Hawking further amplified his fame, presenting him not merely as a scientist explaining complex ideas, but as a philosopher, contemplating time, humanity's destiny, and the delicate nature of our planet. A significant milestone in his cultural legacy was the 2014 film The Theory of Everything. This biographical drama, drawn from the memoirs of his first wife Jane, chronicled his university days, the devastating onset of his illness, and his early scientific triumphs. The movie garnered immense critical acclaim, earning actor Eddie Redmayne an Oscar for his portrayal, and making the scientist's personal journey deeply resonant for millions. His influence even extended to music, where his digitized voice was famously sampled by bands like Pink Floyd and U2, integrating his profound words into the fabric of their art. This role cemented his image not just as a figure in science, but as a genuine icon of modern culture. You see, Stephen Hawking serves as a rare example of how scientific thought can transcend the boundaries of laboratories and academia. His likeness became an inspiration. His voice was featured in films, animated shows, and music, and his name was recognized even by those completely unfamiliar with physics. His cultural influence was, in my view, as immense as his scientific achievements. He made the cosmos a relatable part of our daily lives, becoming a testament to the power of the human spirit and reminding us that even the most severe limitations cannot restrain the mind. But you should know that Stephen Hawking was more than a scientist buried in equations and theories. He often spoke as a philosopher contemplating the destiny of our entire species, and his words frequently carried the weight of both a warning and a call for action. A central theme in his reflections was the inherent fragility of humankind. He held the firm belief that by confining ourselves to Earth, we expose our civilization to the risk of global catastrophes. He pointed to threats like nuclear war, environmental collapse, unchecked artificial intelligence, or widespread pandemics, any one of which could spell our end. Because of this, Hawking consistently advocated for humanity to prepare for deep space exploration, envisioning a future where we establish self-sufficient colonies on the Moon, Mars, and beyond, thereby securing our survival for millennia. Now, he also gave a great deal of thought to our technological progress. On one hand, you could see his admiration for innovation and his conviction that technology would be our ticket off this planet. On the other hand, he cautioned that the unrestrained advancement of artificial intelligence and genetic engineering could culminate in disaster. His memorable declaration that AI might be humanity's final invention has truly become a part of history. He also devoted particular attention to the climate crisis. Hawking warned that if we fail to alter our approach to the environment, our planet could suffer the same fate as Venus, becoming a greenhouse hell with unbearable surface temperatures. He made it clear that global warming isn't some far-off possibility, but an immediate danger that you and I must confront right now. But you shouldn't think his forecasts were entirely grim. At his core, Hawking believed in the power of human intellect and our scientific capabilities. He often said that our innate quest for knowledge and our capacity for cooperation are the very things that can save us. He imagined a future where humanity travels to distant stars, discovers new forms of life, unlocks the universe's deepest secrets, and achieves unprecedented longevity. Hawking's philosophy essentially presented humanity with a choice. We could either bring about our own destruction through irresponsibility, or we could evolve into a magnificent civilization by applying our knowledge wisely. For him, science was the very key that could unlock that brighter future. These powerful predictions elevated Hawking from a mere scientist to a prophet of our era, whose voice was heeded not only by physicists but also by politicians, entrepreneurs, students, and people from all walks of life, reminding us that our destiny is ultimately in our own hands. Now, let's turn to a topic Stephen Hawking frequently addressed, one that fascinates humanity just as much as cosmic mysteries: the question of God and religion. His thoughts on this often ignited fierce debates because, as you'll see, he approached the subject not as a theologian, but as a physicist, determined to explain the world using the laws of nature. He was raised in a family that didn't adhere strictly to religious practice. His parents viewed faith more as a cultural tradition than a rigid set of beliefs. This led him from a young age to ponder a fundamental question. If the universe is governed by laws that dictate its evolution, is there any room for divine intervention within those equations? In his books, you'll find Hawking often wrote about the mind of God. However, what he meant by this wasn't a personal, conscious deity, but rather the complete set of physical laws that govern our universe. His famous statement was, "If we find a complete theory, we will know the mind of God." While many took this to mean he was a believer, Hawking himself clarified that he used the word God metaphorically, as a symbol for ultimate knowledge. In his later works, he became even more direct with his viewpoint. In the 2010 book, The Grand Design, for instance, He wrote that you don't need to invoke a creator to account for the universe's origin. He argued that the fundamental laws of physics, such as gravity, are entirely sufficient to explain how the cosmos could emerge spontaneously from nothing. He maintained that physics alone provides all the tools we need to comprehend the world, making a religious explanation unnecessary. As you can imagine, these statements prompted a significant backlash. Religious figures from various faiths criticized Hawking, accusing him of promoting atheism and dismissing the spiritual dimension of life. Yet, he consistently stressed that his goal was not to demolish faith, but simply to offer a scientific perspective on the world. It's interesting to note that he didn't dismiss spiritual questions entirely. He acknowledged that science and religion fundamentally pursue different objectives. As he saw it, science addresses the question of how things work, whereas religion often grapples with the question of why. For his own journey, however, he chose the first path, convinced that scientific knowledge is what makes our world truly understandable. Many philosophers observed that Hawking's position aligned closely with scientific deism. He seemed to recognize the existence of universal laws, so beautiful and harmonious they could be described as divine, yet he did not believe in a personal God who steers the course of human events. This created a complex legacy regarding his views on religion. For some, he was a champion of atheism. For others, he was someone who spoke of God's mind using the language of science, showing us that the quest for truth can take many forms. And while Stephen Hawking will be remembered in history as a pioneering cosmologist and researcher of black holes, I think it's crucial to also recognize him as a teacher who left an indelible mark on his students and colleagues. His work at the University of Cambridge spanned several decades, and many of the young scientists who passed through his seminars and lectures later became distinguished experts in their own right. His pedagogical approach was a significant departure from traditional methods. His physical condition prevented him from giving extended verbal lectures, so he instead guided his students through focused concepts, equations, and probing questions. He prized innovative thinking over simple memorization, and many of his former students remember him posing a single, transformative question that would fundamentally alter their understanding of a complex issue. Perfection was never his expectation for his students. Instead, he fostered an environment that celebrated audacity and creative exploration. This unique methodology motivated them to pursue independent thought and question accepted theories, a characteristic that defined his educational influence. As his students frequently noted, Stephen didn't just teach physics, he taught us how to think, a testament to his gift for seeing problems with profound depth and imparting that same quality to others. Even with the profound challenges of his illness, he remained a dynamic presence at scientific seminars. He would attentively follow student presentations, posing questions via his speech synthesizer in a manner that was always respectful and never condescending. His feedback was known for being both incisive and encouraging, making young researchers feel valued and heard. Beyond the academic world, Hawking's influence extended globally, inspiring millions through his popular books and public appearances. A great number of young people credit his work, particularly A Brief History of Time and his documentaries, as the catalyst for their decision to enter scientific fields. In this way, his role expanded to that of a genuine educator for all of humanity. The very image of him, a mind triumphing over physical adversity, resonated deeply with the public. He successfully demonstrated that physics is far from a sterile discipline. It is a profound journey toward comprehending our very existence. His life became a powerful testament to the idea that one can relentlessly pursue and disseminate knowledge, even when faced with the most extreme challenges. Hawking also embodied the principle of scientific integrity. He openly acknowledged his errors and readily adjusted his positions in light of new evidence, instilling this same intellectual honesty in his students. This commitment elevated him from a mere mentor to a genuine role model, leaving a legacy that includes not only his theories, but an entire generation of researchers shaped by his philosophy. His enduring influence is found not just in publications, but in the spirit of those he inspired to pursue science. Stephen Hawking's work was never limited to specialized academic papers or lectures for experts. His synthesized voice became a prominent feature in global conversations, tackling subjects of critical importance to the entire human race. He consistently warned of worldwide dangers like climate change, nuclear proliferation, and overpopulation, and his blunt, unambiguous statements were frequently highlighted by the media, because he never hesitated to speak candidly about the perils he foresaw. To illustrate his concerns, Hawking frequently cautioned that unchecked global warming could render our planet uninhabitable. He would point to Venus, where a runaway greenhouse effect has resulted in surface temperatures of 460 degrees Celsius, as a cautionary tale. For Hawking, this served as a clear and urgent message about humanity's duty to act as responsible stewards of Earth. He was also a passionate proponent of international collaboration, recognizing the deep connection between science and politics, and the impossibility of tackling global dangers in isolation. He urged countries to work together on issues from climate change to space exploration and the governance of artificial intelligence. Central to his outlook was the long-term survival of civilization, which he powerfully articulated in lectures with the stark choice. Humanity has a choice. Either we become a spacefaring species or we destroy ourselves. A statement that was both an inspiration and a grave admonition. Remarkably, Hawking possessed a unique talent for communicating with a broad audience, from political leaders to the general population. He employed clear and powerful metaphors that rendered complex concepts understandable, discussing cosmic phenomena and Earth's future in a language that captivated everyone from students to heads of state. Furthermore, he was a dedicated supporter of charities focused on researching amyotrophic lateral sclerosis, or ALS, the condition he endured for most of his life, becoming a beacon of hope for people with disabilities by proving that physical constraints are no barrier to profound intellectual and spiritual accomplishments. Even during the last years of his life, Stephen Hawking was a central figure for both the public and his scientific peers. His health was in decline, yet he persisted in writing books, granting interviews, and taking part in conferences, continuing to be a source of inspiration for people across the globe. As his illness advanced, he was left with only the ability to operate his computer through a small muscle in his cheek, a task demanding extraordinary time and concentration. His refusal to surrender, and the sheer effort behind every article and speech, stood as a powerful testament to his indomitable spirit. Throughout the 2010s, he released several new publications, most notably The Grand Design, which he co-wrote with Leonard Mlodinow. In this work, he elaborated on the concept of the multiverse, a theoretical ensemble of all possible universes, and contended that the universe's existence could be explained by the laws of physics alone, without invoking supernatural intervention. The book ignited spirited discussions and successfully brought the philosophical dimensions of cosmology back into the public spotlight. He also persisted in alerting humanity to existential risks, with his speeches increasingly stressing the urgency of preparing for the colonization of other worlds. It was his firm belief that humanity faced a choice between becoming an interplanetary species within the next few hundred years or facing eventual extinction. Despite his physical condition, Hawking's engagement was anything but passive. He was involved in space exploration initiatives and endorsed a project to send miniature probes to Alpha Centauri, our closest neighboring star system. A project known as Breakthrough Starshot ignited fresh aspirations of interstellar journeys for millions. The last years of his life were also distinguished by significant cultural moments. In 2014, the movie The Theory of Everything was launched, featuring a brilliant portrayal by Eddie Redmayne. The film secured an Oscar, and Hawking himself remarked on his astonishment at the precision of the actor's performance, which brought his personal story of love, struggle, and genius to an even wider audience. He maintained his sharp sense of humor right until the very end, often joking in interviews. His renowned quote, "Look at the stars, not at your feet," evolved into a guiding principle for countless individuals. Stephen Hawking passed away on March 14, 2018. Which happened to be Albert Einstein's birthday. This symbolic alignment was interpreted by many as a meaningful sign, where the life of one great scientist concluded on a date forever tied to another. He was 76 years old, a remarkable feat for someone who was initially given just a few years to live as a young man. His passing was an event of global significance. On the day of his funeral, Cambridge was adorned with flowers as people from all corners of the globe shared their messages of gratitude. His ashes were laid to rest in Westminster Abbey, adjacent to the graves of Isaac Newton and Charles Darwin, cementing his place alongside them in the annals of science. Hawking's final years were defined not by despair, but by a dedication to activity, science, and philosophy. He bequeathed to the world not only groundbreaking discoveries, but also a powerful example of living a life by conquering what seems impossible. Following his death in 2018, the world was once again reminded of the profound legacy he inscribed in human history. A life that symbolized not just scientific achievement, but also courage, spiritual fortitude, and a deep love for knowledge. His contributions to science are immeasurable. The work he conducted with Roger Penrose on singularities laid the groundwork for modern cosmology, while his theory on Hawking radiation fundamentally altered our comprehension of quantum physics and gravity. Furthermore, his no-boundary proposal has unlocked new avenues for studying the cosmos. And even though many of his concepts are yet to be experimentally verified, they have already been integrated into the scientific worldview. His role in popularizing science was equally important. The book, A Brief History of Time, motivated millions to contemplate the universe, serving as the first introduction to science for many. It demonstrated that physics could be captivating as well as complex. This tradition was carried on in his subsequent works, such as The Universe in a Nutshell and The Grand Design, which continued to make profound ideas accessible to the public. A significant part of Hawking's legacy is his public image. A man confined to a wheelchair and unable to speak became a potent symbol of the mind's power. He demonstrated that even the most severe physical circumstances cannot extinguish the quest for knowledge. His life story continues to inspire individuals with disabilities, proving that physical limitations are no barrier to the human spirit. His influence also permeated popular culture, where he was celebrated as a hero in films, television series, and music, with his words resonating across the globe. Artists, writers, and directors drew inspiration from his persona, transforming him into a scientific icon who was recognized far beyond academic circles. His philosophical legacy holds a unique place, as he not only explored scientific inquiries but also contemplated humanity's future, its potential risks, and its enduring hopes. He issued warnings about global dangers but consistently preserved a sense of optimism. His advice to "look at the stars, not at your feet," serves as a timeless reminder that humanity must always aspire to greater things. Today, active research continues to build upon his ideas, with scientists striving to confirm Hawking radiation, debating the paradox of information in black holes, and investigating hypotheses about a multiverse. No matter what discoveries the future holds, Hawking's contributions are permanently woven into the fabric of science. His legacy, therefore, extends beyond his publications. It represents a profound belief in the power of the human intellect. He proved that even when confronted with illness and immense limitations, achieving the impossible is within reach, making his life a source of inspiration for millions, and his ideas a guiding light for future scientific exploration. Stephen Hawking consistently highlighted that his fascination with the cosmos was deeply intertwined with his interest in humanity. His thoughts about the universe invariably circled back to fundamental questions about our existence. Who are we? What is our purpose? And what does our future hold? He proposed that humanity finds itself at a pivotal point in its development, possessing both the knowledge to explore space and the technologies to overcome disease and prolong life. At the same time, he recognized that these very advancements render us vulnerable, as they can be wielded for destructive purposes if not managed with wisdom. Hawking held a firm belief in the strength of the human mind, stressing that our instinct to ask questions and pursue answers is what defines our species. He considered our unique ability to comprehend the laws of the universe a marvel that transcends any religious explanation. However, he also cautioned against our destructive tendencies, stating, "We are an aggressive species, and it is this trait that helped us survive in the past, but now it could destroy us." He argued that humanity must learn to foster cooperation and adopt a global perspective to avoid facing catastrophic challenges. For him, the cosmos was more than just a subject for academic inquiry. It was a profound lesson in humility. When you gaze at the stars, you grasp just how minuscule we are on a universal scale. And he believed this realization should unite people rather than create division. Hawking dreamed of humanity evolving into a spacefaring civilization, viewing it not merely as a survival strategy, but as a higher calling. He often said, "We must leave Earth and settle on other planets. This is our chance to avoid catastrophes and continue our evolution." In conjunction with this vision, he was convinced that the meaning of human life is rooted in the pursuit of knowledge. He never ceased to affirm that science is the most significant achievement of civilization, as it is through science that we are able to understand our place in the world. He taught us that by looking up, we not only see the stars but also find our own path forward. For Stephen Hawking, each new discovery represented a step toward understanding our very nature. His perspective on humanity was a blend of realism and optimism. He acknowledged the perils we face but had faith in our ability to surmount them. He recognized our inherent aggressiveness, yet trusted in the ultimate power of reason. While he saw our cosmic insignificance, he believed this is precisely what grants us our unique distinction. His words serve as a powerful reminder. The fate of humanity is not predetermined, but rests on the choices we make, giving us the power to be a civilization that vanishes or one that reaches for the stars. Although Stephen Hawking gained renown for his discovery of black hole radiation in the 1970s, this subject remained a constant companion throughout his entire life. He revisited it repeatedly, refining his ideas and engaging in passionate scientific arguments that persisted even in the final years before his passing. A central mystery that always remained was the information paradox. If black holes truly evaporate as he theorized, then what becomes of the information about the matter that has fallen inside them? For a considerable time, Hawking maintained that this information was lost forever. However, influenced by emerging concepts and compelling arguments, he later conceded that it is likely preserved, though in a highly unconventional form. In 2015, he put forward a new hypothesis, suggesting that information might be retained on the event horizon, almost like a hologram. This idea shares similarities with the holographic principle, a concept that has gained significant traction in theoretical physics over the past few decades. If information is truly encoded on the boundary of a black hole, this implies it doesn't vanish but simply transforms into a different state. This theory offered a middle ground that could reconcile the principles of quantum mechanics with general relativity. It paved the way for the potential creation of a future theory of everything, a goal that Hawking pursued with great passion. Still, the discussions were far from over, as many scientists continued their search for evidence and greater clarity. Crucially, Hawking was never hesitant to revise his own positions. For him, science was a living, evolving process. He famously said that making mistakes is a normal part of discovery, and the key is to acknowledge the error and continue forward. This honesty, and his readiness to re-examine his own conclusions, established him as a role model for his colleagues and students. Black holes were more than just an object of study for Hawking. They were a symbol of the universe's profound mysteries. He often used them as a metaphor, famously stating, "Black holes are not so black." This line evolved from a scientific assertion into a philosophical declaration, suggesting that even in what appears to be total darkness, a flicker of light can exist. Today, his work on black holes continues to be a major field of study, with scientists actively searching for experimental proof of Hawking radiation and creating models that unify quantum mechanics and gravity. Even after his death, debates surrounding black holes remain a central focus in physics, and his influence is still profoundly felt. In this way, black holes became not just the subject of Stephen Hawking's scientific inquiry, but an integral part of his enduring legacy. His courage in exploring them fundamentally altered modern cosmology and continues to fuel the ambitions of a new generation of researchers. Stephen Hawking frequently spoke of science as a force capable of uniting people in a way nothing else can. He perceived it as a universal language, accessible to all, irrespective of their country, culture, or faith. The laws of physics are identical for everyone, and this simple fact gave him hope that humanity could transcend its divisions and jointly pursue answers to the universe's greatest questions. He stressed that science is more than just an accumulation of knowledge about the cosmos. It is a critical tool for humanity's survival. Through science, we have developed cures for diseases, learned to harness energy, and begun our exploration of space. However, he also warned that these same breakthroughs could become existential threats if applied without wisdom. which is why he felt the mission of science is to teach responsibility, as well as to uncover truth. Hawking viewed science as a power that could unite humanity, foster collaboration, and equip us to confront the challenges ahead, a vision that remains one of his most powerful legacies. He consistently advocated for international cooperation, believing that global issues like climate change, nuclear proliferation, overpopulation, and the rise of artificial intelligence are too vast for any single nation to solve alone. He was convinced that only through a united effort could humanity successfully navigate these monumental challenges. He saw science as a natural bridge connecting nations and cultures, and he placed special emphasis on humanity's future in space. He imagined that the exploration of the Moon, Mars, and other celestial bodies could become a grand project that brings all countries together. In the same way that building the pyramids or launching the first spacecraft once galvanized entire nations, settling space could become a common purpose for all people. Hawking's philosophy was that humanity elevates itself when it gazes at the stars. His famous declaration, "We are just advanced apes on a small planet orbiting an average star, but we have the ability to understand the universe, and that is what makes us special," captured his belief that our true power lies not in weaponry or wealth, but in our capacity for reason. For him, science was not only a method for deciphering cosmic laws, but also a direct path toward human unity. His voice served as a reminder that if we wish to survive and flourish, we must collaborate rather than fight. One topic that particularly troubled Stephen Hawking was the future of artificial intelligence, and he was among the first prominent scientists to speak candidly about the potential risks tied to its advancement. Stephen Hawking readily admitted that artificial intelligence could yield extraordinary benefits for our species. He envisioned it aiding in medicine, overseeing intricate systems, pioneering space exploration, and tackling environmental crises. In his view, intelligent machines had the potential to carry out tasks far beyond our own capabilities, thereby dramatically accelerating the pace of scientific discovery. Yet, he also issued a stern warning. If the evolution of AI proceeds without careful oversight, the results could be devastating. He articulated that engineering a truly autonomous artificial mind would represent either the greatest triumph or the most profound disaster in the story of humankind. What seemed to trouble Hawking most was the prospect of AI eventually eclipsing human intellect. He often posed the critical question of whether humanity could maintain authority over its own creations. After all, you have to consider that intelligent machines could operate with a speed and efficiency that far surpasses our own, leading to a future where we might irrevocably lose command. These were not abstract fears. Hawking insisted that we must proactively establish safety protocols and ethical frameworks to govern the use of AI, calling for global collaboration to prevent the technology from sparking a new arms race. Interestingly, you can see a certain duality in his position, as Hawking himself relied on technologies that were forerunners to modern artificial intelligence. His renowned communication system, the very tool that gave him a voice, incorporated machine learning elements that progressively adapted to his unique style of expression. This allowed him to work with greater speed and effectiveness. This personal experience reflected his broader philosophy. Science and technology are inherently neutral forces, and their ultimate impact, for good or ill, is determined solely by how we choose to apply them. Today, his cautionary words feel exceptionally pertinent. Artificial intelligence is advancing at a breathtaking rate, and a growing number of researchers now echo Hawking's sentiment. The destiny of our civilization hinges on our capacity to wield these powerful technologies with wisdom and responsibility. His voice served as one of the earliest and most crucial alarms, and it is perhaps due to such foresight that the world has finally begun to engage in a serious dialogue about the profound ethical and philosophical questions surrounding AI's development. Stephen Hawking secured his place in history not just as a brilliant scientist, but as an unparalleled popularizer of science. It's hard to overstate his contribution to igniting a passion for the cosmos in millions of people globally. He possessed a unique talent for translating the most convoluted theories into accessible narratives that you could listen to before sleep, letting your mind drift among the great puzzles of the universe. His book, A Brief History of Time, which came out in 1988, was nothing short of a cultural phenomenon. Written in straightforward language for a broad readership, the book sold millions of copies across the world. It sparked a fascination with cosmology in people who had never before shown an interest in physics, making Hawking a household name and elevating him to the status of a cultural icon. In the years that followed, he authored other significant works, including Black Holes and Baby Universes, The Universe in a Nutshell, The Grand Design, and Brief Answers to the Big Questions. Each one continued his mission of demystifying science, making you feel as though you were a participant in a grand expedition toward truth. Hawking's renown reached far beyond academic circles as he became a hero in films, television series, and even cartoons. He made appearances in The Simpsons and The Big Bang Theory, and was the subject of numerous documentaries about the cosmos. His image, a man in a wheelchair speaking through a speech synthesizer about the universe's deepest secrets, transformed into a powerful symbol of intellectual courage and indomitable spirit. It was largely thanks to him that science began to shed its reputation for being tedious and remote, instead becoming an integral part of popular culture. His lectures consistently drew capacity crowds, his interviews were quoted around the globe, and his reflections on humanity's future sparked discussions among not only scientists but also politicians, journalists, and philosophers. You can also measure his influence by the thousands of young individuals who were inspired by his books and speeches to pursue careers in physics and astrophysics. Hawking cultivated a new generation of researchers by demonstrating that science is not merely a collection of formulas but a way of viewing the world with awe and optimism. In this, he became for our era what figures like Galileo, Newton, or Einstein were to theirs. A person who not only revealed new frontiers but made the entire world eager to explore them. Stephen Hawking consistently ventured beyond the confines of purely scientific inquiry. He was captivated not just by the mechanics of black holes or the origins of the universe, but by the ultimate destiny of the human race. His considerations often took the form of warnings, which simultaneously served as urgent calls for action. He contended that our species remains exceedingly vulnerable as long as we are confined to Earth, a planet exposed to numerous threats, from climate change and overpopulation to asteroid strikes and the specter of nuclear war. Consequently, in his assessment, the future of humanity is inextricably tied to our exploration of space. He envisioned a time when people could successfully establish colonies on the Moon or Mars, proposing that we view space not just as a frontier for discovery, but as a vital insurance policy for civilization's survival. As he famously stated, We must evolve into an interplanetary species if we hope to endure for another 1,000 years. At the same time, he pointed to immediate global challenges that threaten to unravel our world, speaking out about climate change, resource depletion, and the dangers of biotechnology. He gave special consideration to how modern technologies, such as artificial intelligence, genetic engineering, and novel forms of weaponry, could shape our future, recognizing their potential as both our salvation and our doom. Yet, despite these grave concerns, his outlook was always underpinned by a sense of hope. He held a deep-seated belief in the power of the human intellect to navigate and resolve great difficulties. He would often repeat his famous advice to look up at the stars, not down at your feet, urging everyone to preserve their curiosity and their unyielding drive for discovery. These concepts elevated him beyond being merely a scientist, transforming him into a philosopher of science. He masterfully blended meticulous calculations with a far-reaching perspective, prompting people to contemplate what might lie in store for their descendants, centuries and even millennia from now. You can still hear his forecasts for the future cited in contemporary discussions on space exploration, climate change, and the overall destiny of our species. It is as if Hawking left you a map that charted not just the threats ahead, but also the potential routes for overcoming them. As we reflect on his story, it's crucial to grasp that Stephen Hawking's inheritance includes more than just his scientific papers and popular books. His legacy is far more expansive, rooted in his ability to show all of humanity the sheer grandeur of thought and the spiritual fortitude needed to conquer the most challenging adversities. For most of his life, Hawking was confined to a wheelchair, unable to speak with his own voice, and almost entirely paralyzed. Yet it was precisely from within these constraints that he succeeded in communicating the magnificence of the cosmos to millions. He offered definitive proof that the human mind is a force that can emit a light more brilliant than any star in the sky. His groundbreaking discoveries regarding black holes, the phenomenon of Hawking radiation, and the origins of the universe are now fundamental components of academic textbooks. His books served as a vital connection, spanning the divide between the most intricate theories and the everyday reader. Moreover, his lectures sparked a fascination with science in audiences that had never before considered the vastness of space. Perhaps his most profound contribution, however, was his personal example. He demonstrated that life retains its meaning even when the body is constrained, and that the capacity to dream and pursue answers can liberate a person from any illness or barrier. Stephen Hawking passed away on March 14, 2018, a date that coincided with Albert Einstein's birthday. This coincidence felt symbolic, suggesting that he had rightfully earned his place among the most exceptional minds in history. The world said goodbye to him as a hero who provided hope and motivation to countless individuals. Today, his iconic synthesized voice continues to resonate in films, recorded lectures, and various media, while his ideas thrive in the research of emerging generations of scientists. His image serves as a powerful reminder that every person possesses the ability to see beyond the apparent and connect with the universe's deepest secrets. Hawking's legacy is an open invitation for you to look to the stars without fear, to ask difficult questions without hesitation, and to dream without limits. Because this is where the true power of science and the human spirit resides.